Here's an interesting example of using three equations and three variables with just 3 points. So let me sketch a graph over here. With just 3 points, 1, 2, -3 and 4, and then 0, 5, it's possible to find a parabola, and actually just one parabola, that will go through those 3 points. So based on how these look, I'm thinking that it looks something like this. So since it's a parabola, it's a quadratic, so we can say that it's quadratic in form, ax squared plus bx plus c. And then over here we've got some numbers for x and y that we can substitute into the equation. So for the first one, it's going to be that y is equal to 2 and x is equal to a 1. So there's the first equation. And now substitute that x is a -3 and y is a 4. So we have a times a -3 squared plus b times a -3 plus c. And then finally substitute the 0 and 5. So 5 for the y value, and then a and 0 is squared plus b times 0 and c. And now we have 3 equations with 3 variables, a, b, and c. So we can simplify them. The top one would be that 2 equals an a times 1, a b times 1, and a c. The middle equation is that 4 equals 9 times a. From squaring the -3, it's a +9. And over here, it's going to be -3b plus a c. And the bottom equation, all of this gets canceled. We just have that c is equal to 5. So then we can do what's called back substitution. Take that c of 5 and substitute it back into these other equations. And the top one would look like 2 equals a plus b plus 5. And the middle one would become 4 equals 9a minus 3b plus 5. And then when we move the 5 over, we have 2 equations with 2 variables. So that would look like, so let's see, subtract the 5. It's going to be that a plus b. When you subtract 5 from this, is going to be -3. And then this is going to be 9a minus 3b equals, again, subtract 5, so it's going to be a -1. And then use either substitution or elimination method. I think I'll use substitution. So solve for a here. It's -b, subtract a 3. And then substitute that into this equation. So it's going to be 9 times a, which is -b, subtract 3, minus 3b is equal to -1. And now distribute the 9, so we'll have -9b minus 27, and then a -3b equals a -1. Alright, so combining the b's, that's going to be -12b, and this 27, add that to both sides, we get a +27, subtract 1 is a 26. So dividing results in b equal to 26 divided by -12, or if we reduce, we can divide by 2 for 13 and divide by 2 for -6. So there's the b. And finally we need to find the a. So substitute that value over here. So a is equal to negative of what b is equal to, then subtract a 3. So a is going to be a positive 13/6. And then for the 3 we could get a common denominator, multiply top and the bottom by 6. So it's going to be 18/6. And then subtract. A 13 minus an 18 is -5/6. So then we've got the A, B, and C, and we can put those back over here. And so the quadratic function, or parabola, is going to look like -5/6x². That inverts it so that the vertex is at the top, the negative does. And then the b is 13 over -6. That's for the x. And then the c is 5. So then we can graph it and see if it's correct. So y equals -5/6x², and then subtract a 13/6x plus a 5. And then zoom standard to see the graph. Hey, it even sort of looks like what I wrote before. And then substitute to make sure that these values are right, because a sketch of the graph, that's not a proof. We need to know that these numbers work in the function that we got. So substitute a 1, and the y value should be a 2. So trace, put a 1. 1, 2 is correct. Next, test the -3 and 4. So type in a -3 and enter. Yes, that works, -3 and 4. And finally, 0 and 5 works. And so we've got it. There is the parabola.